Ms. Math presents Genius Geometry, G5 Triangle Inequality. Let's start off with some triangle basics. All angles add up to 180 degrees. So if we have two measurements, we can use this to figure out the third angle in our triangle. We start with 180 degrees and we subtract the two angles that we have. For the triangle shown here, we use 180 minus 68 degrees minus 54 degrees, which gives us 58 degrees. So our missing angle measures 58 degrees. Next, we're going to see what we need to do to figure out the third side length of a triangle when we're given two of its side lengths. We see here a triangle that has side lengths of 8 and 12, but we don't have the third side length. The third side length must be between the difference of the sides and the sum of the sides. To make this easy, we say the third side is between big minus little and big plus little. 12 is the larger of the two numbers, so I label this big. I label 8 as the little side. So our third side will be between 12 minus 8, big minus little, and big plus little, 12 plus 8. Simplifying, we see the third side is between 4 and 20. What if we're given three measurements and we need to know if they make a triangle? Our rule here is the sum of the smaller two sides must be bigger than the third side. For our first set of numbers, 15, 17, and 35, we add our smallest two, 15 and 17, which gives us 32. Because 32 is not bigger than 35, these lengths could not make a triangle. Next, let's look at 8, 15, and 7. I have to add the smallest two. Notice these aren't in order. 7 and 8 are the smaller two, so that's what I add together. Their sum is 15. Is 15 bigger than 15? It's the same, not bigger, so these lengths do not make a triangle. For our last set, 29, 21, and 9, once again, they're not in order. I add my smallest two numbers, 9 and 21, and I get 30. 30 is bigger than our largest number, 29, so these will make a triangle. We can use the information given for a triangle to place sides or angles in order from least to greatest or greatest to least. Our rule is that the shortest side is across from the smallest angle, and the longest side is across from the largest angle. It helps to draw out a table with columns for angles and sides, and rows for smallest, middle, and largest. Then we use the information we're given to fill out our chart. In this triangle, the smallest angle is angle C, measuring in at 54 degrees. So beside S in our angle column, I write angle C. I can circle angle C and draw an arrow to the side across from angle C. This shows me that side AB is the shortest side. So I can fill that into our table. I see that at 58 degrees, angle A is the middle angle. I can circle angle A and draw my arrow across. That shows me that BC is the middle side. Now we fill in our largest angle, B, and we'll use the same strategy. Circle and draw our arrow. So we see that AC is the longest side. We can use our chart to order our side lengths. Shortest to longest is AB, BC, then AC. What if we're given side lengths and not angles? It's still the same concept, shortest side across from smallest angle, and longest side across from largest angle. In our triangle here, 4 is the shortest side, side EF. I can use the same strategy we did before, but I'm drawing my arrow the opposite way. I start at the side, and I draw the arrow to the angle across from it. So angle D must be the smallest angle. 6, or side DE, is the middle side length. I draw my arrow, which shows angle F is the middle angle. Lastly, 7, side DF, is our longest side. Drawing our arrow across, we see that angle E must be the largest angle. So the angles, in order of smallest to largest, are D, F, and E. Thank you for watching Ms. Math Presents Genius Geometry. See you next time.